we have another example of expressing y equals minus 3 sine x plus 4 cos x in the form of r sine x plus theta. We need to calculate r, we need to calculate theta. And this is slightly different to the one we've just done in the fact that we've got one of our coefficients as negative and one of them being positive. So let's do the template, which is the method with, and that is to expand this out using our sign of a plus b that we know the identity. So we've got y equals r sine of x plus theta. The expansion means that everything inside's got to be multiplied by r, so that'll be r cos theta sine x plus r sine theta cos of x. But we know that y equals negative 3 sine x plus 4 cos x. Now these are the same here, which means that these two must be the same, so that r cos theta equals negative 3, and from that we can say that cos of theta equals negative 3 on r, and over here we've got r sine theta equals 4, so sine theta equals 4 over r. We know that the Pythagorean identity is that sine squared theta plus cos squared theta equals 1. So we know that 4 on r squared plus cos is negative 3 on r squared equals 1. And that means that 16 on r squared plus 9 on r squared equals 1. Multiply right through by r squared and you get 25 equals r squared. And we get, take the square root of both sides, we get 5 equals r. Now, you may be wondering, why don't we use negative for plus and minus? So we got r equals plus and minus 5. Well, we're assuming up here that r, we're only interested in the simple value when r is positive. So yes, we could work out another set of solutions where r is negative, but we'll just concentrate on the solution when r is a positive one. All right, so we've got r is equal to that, so we know that the cos of theta equals negative 3 on 5, and the sine of theta is equal to 4 on 5. Now, we say, okay, we've got to work out theta. Now, we know cos is negative and sine is positive. We draw our CAST. Cos has got to be negative. So cos is negative in both of those two quadrants. Sine has got to be positive. Well, sine is negative down there, so this is the quadrant that we're interested in. If we go second sine of 4 on 5, so on your calculator, shift sine, that should open a bracket, and 4 on 5, we'll get 0.928, which is what we got in the previous question. But that occurs in the first quadrant. We want the corresponding one in the second quadrant, and don't forget we always work off the x-axis, so it'll be pi minus. So my theta will be pi minus 0.928. It's not this one here in the first quadrant, but it'll be going all the way over there and back. And in that case, the sine of that angle will be positive and the cos of that angle will be negative. And if you evaluated that, don't forget pi is just our normal 3.14159, whatever. And we take away 0.928, we'll get 2.214. So therefore we can actually work it out as y equals, now we go back up, r was 5, sine, we didn't have to calculate, x was our variable, and theta now is 2.214.